Hello and welcome to the technology presentation for Bridges Project 2 Year 8 on forces, motion and material properties. Okay, so in Year 8 you'll be making a bridge in your groups, so we should really get some background information on what forces, motion and materials are to inform us on the design and manufacture of the bridges. So forces are basically interactions between two objects, maybe pushing or pulling or stretching or twisting. So if you pushed something over and it fell over, then you'd be getting a reaction of the force U inputted to the object. Likewise, if you were pulling something, so for example, a tug of war would incur a pulling force or stretching. Also, then the opposite of that would be sort of compressive force, which is pushing together, and the twisting force then, such as with a bottle top or a screw top. There are five main types of forces. The first one is tension, and tension is when you are applying force on both sides of the object, so stretching something like we saw in the tug of war earlier. From the picture you can see a suspension bridge, which is tension through the cables holding the bridge up. The second one is compression, which is the opposite of that, which is like forcing two pieces together, like squeezing. So you can see the aqueduct there is actually forcing down onto the ground. The third type is bending. So on the inside you can see that it's being compressed and it's squeezing together. On the outside is under tension, so it's being stretched apart. The fourth type of force is shearing we want to talk about, and that's like a pair of scissors acting together to cut an object. We also see in engineering if an object has had a clean break straight across the profile and that's been sheared across. And the final one we'll talk about is torsion, and that's basically twisting. So if you look at the bottle cap earlier, if you were turning it, it's under torsion. You often find torsion in decorative sort of metal work like candlesticks and things. But if you were to think about wringing out a wet dishcloth, that's torsion. So the next part we want to talk about is motion. And motion is basically the way things move. So in mechanics, there are four general types of motion. That's rotary, oscillating, linear and reciprocating. So rotary is where something just turns around, keeps turning around, turning, like a sort of motor that only turns in one direction, or a clock that just keeps turning round. So oscillating would be a rotary motion but going back and forth. So if you've seen an old grandfather clock like a pendulum swinging back and forth, or the swing in a playground on an arc just swinging back and forth. Linear motion is an object traveling in a straight line in one direction. So if you were to like roll a ball in one direction or a rocket shooting off into one direction. And the last I want to mention is reciprocating, which is going back and forth or up and down in a similar motion. So if you've got like a yo-yo or a piston in a cylinder block and an engine just goes up and down to power the engine. We can change between these types of motion by using simple machines, gears, or things called cams. Now, simple machines are just things like corkscrews or seesaws, as you can see here, where the motion or input is pushing down and it's causing the output to actually go up over the center pivot called the fulcrum. Gears or cogs, as some people like to call them, can change movement directionally, as in like rotationally, or they can change like sort of linear movement to rotational or vice versa. An interesting thing about these gears lined up this way is that the odd ones, like first, third, fifth, travel in one direction, the even ones travel in the opposite. The last thing I want to talk about is a cam. A cam basically is a rotational device that changes the direction. So once this eccentric cam turns, it actually pushes the follower up and down. You see these most often in camshafts in engine components. Material properties are basically how different materials act or react to different forces. So for example, it's a characteristic that best describes the property. So you could describe glass as being brittle because it shatters easily. So if you hit glass hard with, say, a metal object like steel, it would break it. Steel can be described as hard and malleable, and it can be hit with another hammer to make it into a different shape. Then you've got things like rubber bands that are described as being elastic. So once they're stretched, they return to the original shape after being released. There are loads of material properties. I just want to focus on a few. The first one we're looking at is compressive strength. So that's the ability to be able to be squeezed or pushed together. Now, a good object that's got compressive strength would be like concrete. Tensile strength is the ability to withstand the pull-in force. So steel, for example, has got very good tensile strength. Elasticity is the ability for a material to go back to its original form after it's being stretched. So like rubber and rubber bands, that's perfect for that. And finally, brittleness, as discussed earlier, like glass, is an object that will break suddenly with force applied to it, and it's the opposite of being tough. Okay, so thanks for watching that. Year 8, please take the quiz on materials. Good luck. Try your best. Log on to your team's account, complete the quiz. We get it marked for you as soon as possible. Thanks for watching.